Hi, I'm Zachary Crawford, and today we're going to go over gas detector sensor principles. So starting off, we have our 4 gas meters and 5 gas meters. The conventional setup's obviously going to be oxygen, H2S, CO, and LEL. Then you have the option for PID, and we have the option for with or without pump, so passive unit. So first off, we have the Ray Systems multi-ray. We have a multi-ray pumped, which is 4 gas and PID. We have the multi-ray light pumped, which is also 4 gas and PID, just different range on the PID. And we have the multi-ray pro pumped, which is 4 gas and PPB PID. Next up, we have the RKI instruments, which is going to be the RKI 6000. That's a 4 gas PID in toxic or 4 gas in 2 toxic sensors, which we'll touch on here in a little bit. So the types of sensors that we have in both of these units, we have electrochemical, we have catalytic, galvanic, infrared, and then photoionization, which is our PID. So electrochemical sensors. Electrochemical sensors are going to measure the concentration of the gas by oxidizing the gas at an electrode and measuring the current. Next up, we have catalytic sensors. So catalytic sensors are going to measure the concentration gas by coming into contact with a catalyst surface where it's oxidized, and the change in resistance is going to be correlated to the concentration. So galvanic sensors are going to measure the concentration of the gas by coming into contact with the lead fuel cell as seen in the diagram, and that lead fuel cell oxidizes that sample and produces an output that's proportional to the concentration of gas you're trying to monitor. Last but not least, we have infrared sensors. So infrared sensors, they're going to measure the target gas by absorbing infrared radiation and light, and it detects the decrease in radiation and light through the gas to determine the concentration. So starting off, we have the multi-ray, Ray Systems multi-ray. The slots are labeled. Sockets 1 and 5 are your high-powered slots, and sockets 2, 3, and 4 are your low-powered slots, which I'll visit on the next slide. So the Ray Systems sensor types. Here listed, we have the type of sensor, whether electrochemical, infrared, catalytic, and the ranges on them, and whether they're high power or low power. So determining what slots they can fit into in the back of that multi-ray. Next up, we have the RKI GX6000. As you can see in the diagram on the right here, this is the back of the 6000. On the right-hand side of that diagram, you see your standard 4 gas sensor slots. That's going to be your LEL, your O2, your CO, and your H2S. And then on the left side of that picture, you have your labeled 2 smart sensor slots, which we'll touch on here on this next slide as well. Here we have listed the RKI sensors. We have the type of sensor it is, the range on it, and we also have notated whether it's a smart sensor or not, so if it can fit into that slot. To get the most out of your sensor, it's going to take some care. We have pictured here as a warming station or sensor bank. This one is from Ray Systems. All this is going to do is keep a current flowing through your sensor even when it's not plugged into a unit, so it's fresh and ready to go whenever you need it. We also have pictured a cross sensitivity table. This one happens to be for the H2S sensor, but there's tables for each sensor. Last but not least, sensor poisoning. The most serious poisoning we have are silicones. So this is silicanes, silicones, and silicates. Thank you for your time in listening to Gas Detector Sensor Principles. If you have any questions, please contact us here at FEI. Thank you.